So let's go through an example of a static force analysis of a 4-bar link mechanism. So this is a 4-bar link mechanism which is having 4 links. So O2, O4 is the fixed link, O2A is the crank, AB is the coupler, and then BO4 is the 4th link. And then there is a force P which is acting on the 4th link as shown with an angle 40 degree. Now if there is a force P which is acting there, if we want to keep the mechanism in a state of rest, how much torque needs to be applied at the crank? So what should be the value of M12 so that the link 4 does not rotate under the action of force P? So that is what we need to calculate. Now let's break down the 3 links, the 3 moving links with their free body diagrams. So this is free body diagram of link 3, which is a blue color link. So this is a 2 force members. So for static equilibrium, the 2 forces should be equal and opposite directions as shown. So let's consider the force acting at A on link 3 is F23 and at point B is F43. So these 2 forces are acting. Then let's have a look at the free body diagram of the link 2. So link 2 is a 2 force plus external moment member. So it is not a purely 2 force member. It is also having an external moment, which is the torque M12. So this torque M12 will act against the impending motion of this force P. So it will be in a counterclockwise direction. And this F32 force, which is at A of the crank, will be in the same direction of AB. So F32 will be in the same direction of F23 but in opposite direction. So F32 is same in magnitude as F23 on free body diagram of link 3. And F12 is a reaction which will be created at the reaction point or pin joint of the crank. Now let's have a look at free body diagram of link 4. Now link 4 is a 3 force member. So there will be 3 forces on link 4. First force over here is the F34, which is again similar to this case of F32 and F23. F34 is opposite in direction to F43 of the free body diagram on link 3. So both are having the same magnitude, but F34 is in opposite direction. And the direction is already known, which is in the direction of the link AB. Then P, whose direction is known and the magnitude is also known. So we can draw link P. And then there is the reaction force, which is created at the pin joint O4, that is F14. So the condition for equilibrium for a 3 force member is that the lines of actions of all the 3 force should intersect at a point. So if you are extending the line of action of F34 and extending the line of action of P, and then we create a point, an intersection point over there. And then if we draw a line to O4, we will get the line of action of F14. So along with the force balance, we also need to do the moment balance. So this is the moment balance equation. If you are finding the moment at point O4, then it will be F34 into the perpendicular distance from O4 to the line of action of F34, which is Y. This is the perpendicular distance between O4 and the line of action of F34, minus P into X. So X is the perpendicular distance between the line of action of P from O4. So F34 into Y minus P into X should be equal to 0. So this is a moment balance equation for link 4. Also we can write the same moment balance equation for link 2 as well. So if we are finding the moment at O2, so F32, that is this force, into the perpendicular distance between the line of action of F32 and O2, that is Z over here. So this is a perpendicular distance between line of action of F32 and O2. So F32 into Z, that is force into moment arm, minus M12, because M12 is the external moment which is being applied. So F32 into Z minus M12 should be equal to 0. So the net moment should be equal to 0 for link 2. So now let's go through the procedure for finding M12 quickly if P is known. So first we need to draw the free body diagrams of all the 3 links. Link 3 is a 2 force member. It is having equal and opposite forces F43 and F23. Link 4 is a 3 force member. It is having 3 forces F34P and F14. So we need to take moment about O4 and find out this moment balance equation. F34 is not known in its magnitude. So we need to find F34. Because Y, P and X are known, we can find F34. Once we find F34, we need to find this intersection point and connect it to O4. So we will get the direction of F14. So direction of F14 is got. Then we can create this force triangle. So we have P, we have F34. Now the enclosing vector will be F14. So if we are closing this vector polygon with F14, we will get the value of the magnitude of F14 as well. So all the three vectors in link 4 will be known. So then we need to find F23 in link 3. So F23 in link 3 is minus F43, which is equal and opposite, and F43 is minus F34, or minus F43 is equal to F34. So we will get F43 from F34 value from the link 4 free body diagram. And link 1, on link 1 F32 is the same as F23 in magnitude. So that value also we can get because it's equal and opposite, so we can get the value of F32. So once we get the value of F32, we can calculate M12 using this moment balance equation. Since Z is known, because Z is from geometry, so F32 into Z minus M12, from that we can get the value of M12. So F12 can be calculated easily from this diagram because F12 force direction should be equal and opposite in direction to F32 for this to have static equilibrium, because there will only be a moment and that moment will be neutralized by M12. So F12 has to be equal and opposite direction to F32, but it is acting at O2. So F12 is also found out. All reactions are found out and the torque required to hold the mechanism in place are found. That is M12 will be found when P is applied.